Welcome back to the Deep Dive, where we deliver the absolute architectural reality beneath the marketing buzz. Today, we are ripping apart the Agentforce guide. Forget the feature checklists. This deep dive is about operational control, system governance, and the brutal reality of integrating non-deterministic AI into your critical CRM stack. This is the conversation technical leadership needs to have right now.
Precisely. We are so far past the point of treating generative AI as some, neat add-on. Agentforce is not a feature. Let's be really clear on that. It is a fundamental shift in the CRM operating model. For architects building on the Agentforce 360 platform, you are now designing a completely new type of software. It's one defined by its capacity for planning, reasoning, and acting, all via LLMs.
And that introduces the core problem, non-determinism.
It introduces inherent, unavoidable non-determinism.
Yeah.
Your primary job shifts from writing rigid automation code to mastering the art of governance over that ambiguity.
Okay, let's unpack that core definition, because I think this is where the confusion starts for a lot of people. We're explicitly differentiating the Agentforce agent from, say, a generic chatbot or a basic copilot or even an advanced prompt template. If they all use LLMs, what is the core technical differentiator that mandates this whole new governance mindset?
It all boils down to two words: autonomy and execution. A traditional chatbot or copilot. It's reactive, it takes an input, it generates a single output, text, a snippet of code, a suggested action. It's basically a very sophisticated lookup or summarization tool.
Right.
An Agentforce agent, however, is proactive. It's goal-driven. It gets a query or a system event, and it can reason autonomously to figure out the path to an objective. It determines what data it needs. It identifies which external systems, APIs, databases it has to engage. It executes multi-step actions, observes the results, and then it iterates.
So the line is drawn at the decision, action, observation loop.
Absolutely. That capacity to reason, to adapt dynamically based on the LLM, and to execute a series of external actions without immediate human oversight, without rigid, pre-written conditional logic. That is the architectural line in the sand.
And that implies a completely different security model.
It means the agent is managing complexity, state, external dependencies, which, yes, requires an entirely different security and governance model than just masking PII in a text generation prompt.
That sets the stakes incredibly high. If the core capability is dynamic, multi-step reasoning and action, then the system has to have explicit, reliable mechanisms to control that behavior.
Correct. And that's our mission today. We're going deep into the Atlas reasoning engine, the definitive brain of Agentforce. We need to dissect the three foundational components: topics, instructions, and actions, because that's the metadata you use to guide the LLM. And critically, we have to understand why the architectural dependency on Data 360 isn't optional. It is the mandatory foundation. It provides the context, the audit trail, and the security grounding.
All right, let's start at the beginning of the architectural pipeline. Every single practitioner faces this choice. When is a simple prompt template enough, and when must you escalate the complexity and, frankly, the overhead by building a full agent?
This is the first test of architectural sobriety. And the truth is, most simple, repetitive, high-volume tasks do not require an agent. If your job is stateless utility, the prompt template is your answer within the Agentforce 360 platform.
Okay, so let's define that domain. Where is the prompt template most effective?
The prompt template, which you'll often configure through the prompt builder, is a highly structured, reusable piece of configuration. It's fantastic at RAG Retrieval-Augmented Generation. It dynamically injects data from the CRM based on the current context. And crucially, it integrates seamlessly with the trust layer.
Meaning security is baked in?
Yes, security permissions are maintained. Confidential data is masked before it ever even hits the LLM context window. It's powerful, it's secure, and it's highly efficient for its intended purpose.
But the limitation is fundamental, correct? There's a hard ceiling.
It is the hardest, most unyielding limit in the system. The prompt template is a single-turn interaction. It is inherently completely stateless. It retains zero memory across successive requests. It has no capacity to decide, to evaluate, or to perform any kind of multi-step reasoning. Input in, text out. That's the end of its life cycle.
So if I need to summarize a long, complex support case note or generate a structured follow-up email from a template, that's the sweet spot. The context is stable, the case record itself, the output format is predictable, and no evaluation of alternate paths is needed. Perfect for simple classification or text normalization.
Exactly. That is the sweet spot. It's fast, it's cheap to run, and it's entirely predictable. The instant your requirement shifts, the moment the system needs to maintain state or adapt based on an external response or execute a sequence of interdependent steps, You move directly to the agent layer. You need an agent when the system has to analyze the situation and decide what to do next, not just what to say.
Give us the execution difference. I mean, why can't I just chain multiple prompt templates together using a traditional flow? What's stopping me?
You could hard code that chain, but then the process logic is deterministic. It's all human-defined branching. You've pre-scripted every possible path. An agent executes true multi-step planning, and that planning is driven by the LLM's reasoning capacity. When an agent calls an external action a flow, apex, an API, it receives the output of that action. We call it the observation. The agent then uses that observation to reevaluate its state and decide the next optimal action. A prompt template can't do that. It can't absorb external feedback and self-correct.
So the necessity isn't really about using AI for raw intelligence. It's about using AI for autonomous orchestration and state management in complex, unpredictable workflows.
That's it. That's the core distinction. And when is this necessary in the enterprise? In environments that are dynamically changing, where multiple valid decisions exist, or where the system has to substantially aid or even replace human judgment in a complex cycle. Think about triaging millions of incoming support cases, classifying them, routing them, verifying permissions, and maybe triggering an external process like an order cancellation, all in one seamless conversation. The design decision is stark. Stateless utility. That's the prompt or autonomous orchestration. That's the agent.
And just to solidify the architecture, a prompt template isn't excluded from the agent. It just becomes one of the tools in the agent's belt, right?
Exactly. The prompt template can be encapsulated within an agent as a specific single-step action, maybe for summarizing input data before calling a much larger flow. The agent decides when to use that summarization prompt based on its overarching plan. But the prompt itself, it remains that core stateless utility within the larger stateful decision-making framework of the agent. The agent layer exists purely to control that inherent complexity.
That makes perfect sense. We've established the why for the agent. Now let's pivot to the control plane, the Atlas reasoning engine. This is the core decision maker. It's where architects have to insert their governance levers. If we fail here, the entire system is basically ungovernable.
Atlas is the execution heart. It translates user intent, the utterance, into specific executable actions. And it does this using a very carefully structured sequence of internal prompts and code. For technical leaders, understanding its execution flow, it is not optional. It's the only way to effectively insert your governance and control.
The Agentforce documentation points to 3 foundational levers. It calls them metadata control, which is the right term. These are the components we as architects use to design the internal prompts the Atlas engine relies on.
Right. Let's start with the first one, topics.
Okay, what is their core purpose?
Topics define the agent's expertise and scope. Think of them as the jobs to be done. They dictate the critical initial step of classification. And if your topic inventory is bloated, or if the topics overlap conceptually, let's say you have product troubleshooting and technical support queries, and they're too similar, you're introducing semantic ambiguity.
Which leads to the agent getting confused right at the start.
It leads directly to inconsistency and inaccuracy in the agent's initial classification decision. Architects have to treat topics like strictly defined departments with mutually exclusive expertise.
Second lever, instructions. Now, this seems like the most obvious control, but it also feels like it carries the most risk, which I know we'll get into.
It does carry risk. Instructions are the primary LLM guidance. They inject that non-deterministic business context, they direct the conversation flow, they dictate the required sequencing of steps, and they set the conversational tone. They tell the LLM how to behave within the boundaries of a given topic. This is crucial for things like empathy modeling, handling minor exceptions, and guiding the dialogue structure.
And third, the deterministic part, actions, the executable logic.
Actions are the agent's toolset. This is the access point to your deterministic logic. Flows, Apex, external services, or even those encapsulated prompt templates. This is where the actual work gets done. And the key design principle for actions is mandated reusability. An action, like, say, retrieve customer loyalty tier, must be architected once as an idempotent service. It should be callable across any relevant topic. That minimizes duplication and maintains a single source of truth for your business logic.
Okay, now let's get into the gears of the machine. The guide outlines an 8-step reasoning loop. We need to detail this sequence and emphasize where architectural input either dictates success or guarantees failure. Step 1, invocation. Pretty straightforward.
The trigger. It's simple. A user message arrives, a system event fires, or an API call initiates the session. The agent instance is now live.
Step 2, Topic classification. This is the first decision point, and if you don't configure this correctly, it's a single point of failure.
It's absolutely a single point of failure. This is the first and most reductive governance point in the whole flow. The LLM analyzes the user's message, but it only checks two pieces of metadata: the topic name and the classification description. It completely ignores instructions and actions at this stage. If the LLM doesn't find a strong, high-confidence semantic match to one of the available topic descriptions,
It just gives up.
it's immediately routed to the default off-topic status. End of story.
I see the architectural implication there. If I use vague language in my description like handles billing, the LLM has to guess. But if I write an exhaustive classification description, classifies requests regarding invoice delivery status, payment history, or subscription cancellation, then the certainty goes way up.
Precisely. If you fail to provide an exhaustive natural language description of what that topic covers, the agent will fail at the gate. It fails before it even gets a chance to consider your carefully crafted instructions or executable actions. Architects must spend serious time perfecting these descriptions to reduce that margin for error.
Okay, moving to step 3. Context insertion. The topic is locked in. The reasoning engine now compiles the full prompt for the LLM. What goes into that payload?
This is the moment where the LLM gets its operational mandate for the turn. The engine compiles the selected topic's scope, the detailed instructions, the metadata for all available actions, the original user message, and, critically, the recent conversation history.
Let's focus on that last point. The source material says the conversation history is typically limited to the last 6 turns. That 6-turn constraint is a massive technical limitation.
It's a hard architectural constraint you absolutely cannot ignore. That 6-turn limit is set primarily for LLM context window efficiency and performance stabilization. It's not arbitrary. It's a performance and cost decision. So if a user needs a 15-step process, relying on the native LLM memory for anything critical past those initial 6 exchanges is a guarantee of context drift and spectacular failure.
So the architect's job shifts from simple process design to complex externalized state management. You can't trust the agent's memory.
Exactly. If you need to preserve data or conversational state beyond 6 turns, which you always will in any complex enterprise workflow, your primary responsibility is building idempotent, secure actions that explicitly retrieve and update state. You use things like custom variables, which we'll discuss. You have to use the CRM database as the long-term memory, because the LLM itself is designed to forget session history quickly.
All right, step 4, agent decision. This is the core reasoning phase.
Right. Based on that massive context compiled in step 3, the LLM makes its next immediate decision. Does it need to execute an action to gather more data, to change state, or to perform a service? Or does it have enough information to respond to the user directly? This is the point where the LLM chooses its tool from the action metadata you've provided.
Which leads to step 5, action execution and observation.
If an action is chosen, the engine executes the underlying deterministic component, the flow, the apex call, the API. The result of that execution is logged and returned to the Atlas engine as the observation. This observation is the mechanism for closed-loop feedback and correction.
Give me an example of a good observation. It can't just be a simple success or failure Boolean, can it?
No, that would be useless. It has to be highly specific and structured. If the action was validate customer eligibility, the observation shouldn't just be success. True, it should return structured data. Something like eligibility status, eligible, reason code, account in good standing, required next step, schedule cal action. This structured observation data is key because it's immediately fed back into the context for the next step of reasoning.
Which brings us directly to step 6, loop reevaluation, the iterative core of agency.
This is what defines the agent. It doesn't stop after one action. It reevaluates the entire situation based on the new observation and the updated conversation context. It asks itself, did the observation provide the necessary data? Did it resolve the customer's intent? If not, it loops back to step 4 and decides on a subsequent action. This iterative loop continues until the agent is confident it has completed the job defined by its topic scope.
So, if I ask to change my shipping address, the agent might call verify identity as action 1, receive an observation that verification failed. Then it reevaluates and decides to call verify security questions as action 2 before finally being able to call update shipping address as action 3. That sequential conditional execution driven by observation is the engine at work.
Exactly. And that reliance means your action outputs have to be reliable, clear, and focused on driving the next decision. Ambiguous or incomplete observations will paralyze the engine.
Step 7, grounding check. The guide is very clear. This is a critical, mandatory safety and compliance validation step before any text is ever delivered to the user.
It's the architectural safeguard against the inherent non-determinism of the LLM. It's the brakes. Before any response is sent, the grounding check ensures the proposed answer is factually grounded in the source information provided, so are results or action outputs. It also ensures the response strictly adheres to the topic scope and instructions, and, critically for security, it screens for any prompt injection or toxicity risk.
So, if the agent hallucinates a policy change or tries to breach a security limit you defined in the topic scope, this check is what catches it. This is how we introduce deterministic safety into a non-deterministic response generation process.
It's the last line of defense. The system actively validates its own output for compliance and factual accuracy. If it fails this check, the agent doesn't send the response. It loops back and tries to formulate a better, grounded answer. If it fails repeatedly,
Then step 8 is invoked.
right, if it fails repeatedly, step 8 is invoked, which is send response.
So the final validated response goes out. Or if the agent repeatedly fails the grounding check, or if the initial classification fails, it just defaults to a standard non-committal failure message.
Correct. And understanding this 8-step process, especially the role of context, the memory constraints, and that mandatory grounding check, that is the non-negotiable prerequisite for architecting secure Agentforce solutions.
Okay, we've dissected the engine's flow. Now let's talk about the primary control mechanism. The most dangerous architectural failure point seems to be relying on the LLM's interpretation. Instructions are non-deterministic guidance. So how do we ensure critical business logic is respected reliably every single time?
This is the critical transition point for rules-based architects. You have to stop trying to use instructions to enforce critical, immutable business logic. Instructions are suggestions for conversation flow. Their results are variable, they're context-dependent, and therefore they're completely unreliable for compliance.
Right. The LLM is susceptible to semantic noise, to persuasion. If I write an instruction that says, never offer the platinum discount to customers below tier 3, an adversarial or even just a confusing prompt might lead the LLM to interpret never as rarely. Or it might just forget the rule entirely if the context window is flooded with other data.
That variable interpretation is a liability. The result is non-deterministic, it's unreliable, and it's potentially catastrophic for compliance or financial accuracy. The architectural solution is conditional filtering. This is the architect's tool for injecting absolute Boolean determinism into the Agentforce execution flow.
Okay, so if instructions are guiding the car, filters are the road signs, or maybe they're the guardrails that prevent the car from driving off a cliff. How do they operate at a system level to enforce that determinism?
Filters use strict binary variable matching Boolean logic, numerical comparison, string equality. They possess zero semantic understanding. They only evaluate true or false. Their function is absolute. They exclude or include topics and actions entirely from the LLM's current consideration space.
They reduce the LLM's available toolset before the reasoning even begins. This is about shrinking the search space to force adherence.
Exactly. That is the definition of reducing semantic noise. You are preemptively removing irrelevant or unauthorized options, forcing the LLM to choose from a tightly constrained, pre-validated set of available actions and topics. This minimizes hallucination risk and enforces adherence to codified rules that must be absolute.
Let's analyze the application of filtering. The guide points to two critical uses: improving precision in topic classification and enforcing data prerequisites in action selection.
For topic classification, filtering lets you dynamically hide entire topics based on real-time state. For instance, in a highly regulated financial services environment, you might apply a filter that says, if customer verification status is not equal to high assurance, hide the entire wealth management transactions topic.
Even if the user explicitly asks for it.
Even if they ask for it, it prevents the agent from even entering a sensitive domain if security prerequisites haven't been met. It's security enforced at the architectural layer, not the conversational layer.
And for action selection?
For action selection, filters are essential for enforcing data dependencies. The action process customer refund should be hidden until a custom variable, say refund eligibility checked, is true and invoice ID is not null. The filter enforces the prerequisite data availability before the LLM can even attempt to call the action. It prevents all those service failures that come from missing inputs.
If you're advocating for this heavy use of filtering for determinism, I have to ask about the maintenance cost. If I have a complex global agent with, say, 50 topics and 150 reusable actions, and every one of those needs 3 or 4 Boolean filters to control security, data quality, and compliance, am I not just trading the non-determinism of the LLM for the complexity of maintaining a massive, sprawling network of Boolean logic?
That's a legitimate architectural challenge, but it is the necessary trade-off for governance. You are absolutely trading the risk of ambiguity for the complexity of structure. Maintaining hundreds of filters is difficult, yes, but it is deterministic debt. It is known, it is testable, and it is auditable. Relying on instructions for compliance logic, that's non-deterministic debt, which is unmanageable, untestable, and a major liability. The cost of maintaining filters is always lower than the cost of a compliance failure caused by LLM hallucination.
Understood. A necessary cost. Now, let's detail the fuel for these filters, the variable types. We have context variables and custom variables. Understanding their immutability is key here.
Right. Context variables are derived directly from the messaging session, metadata, or pre-chat forms. They are invariable during the lifespan of that session, read-only. They're excellent for initial personalization, customer name, channel ID, the originating record ID, but they cannot track process status or be altered by the agent's actions.
And their primary use is providing that initial context and driving the initial filtering.
Correct. They set the stage. Custom variables, on the other hand, are mutable. They are explicitly designed to store results returned by your actions. This is how the agent tracks the state of a complex process. It's how it knows if verification step 1 complete is true, or if the customer ID was successfully retrieved from an external database lookup.
So if I need to build a 4-step verification process, I'd use 4 separate actions, and each action updates a dedicated custom variable to track its success. Then I use a filter on the final fulfillment topic, checking that all 4 of those custom variables are true. That's the fundamental pattern for injecting absolute control.
That is the pattern. You use the deterministic action to execute the business logic. You store the unambiguous outcome, true-false, in a mutable custom variable. And then you use the conditional filter to enforce the dependency chain based on that variable. This is the only way to hard-code state transitions in a non-deterministic planning engine.
All right, moving into configuration best practices, the hardening phase. If we accept this architectural mandate to control the Atlas engine, how do we build high-performing topics and actions? Let's start with best practices for topics: naming, classification description, and scope.
Topics are the first impression and the first point of failure. Naming is critical. The names have to be short, descriptive, and start with active verbs. Process payment refund, not money stuff. Overly verbose or conceptually overlapping names just dilute classification accuracy. Architects need to maintain a strict inventory and limit the number of active topics.
Why the necessity for a numerical limit? I mean, if my business has 50 distinct functional areas, why can't I have 50 topics?
Because of the computational and semantic cost back in step 2, the LLM has to classify the user utterance against every single topic name and classification description in the list. As that list grows, especially past 15 or 20, the accuracy drops off a cliff. It's due to the increased search space and the inherent ambiguity of natural language. You need precision over volume. You must consolidate complex multi-step processes under a single, well-defined topic.
Okay, next, the classification description. This needs to cover every possible permutation of a user request.
It's the natural language contract for that topic. It must be specific and exhaustive. A bad description is handles order questions. A strong, precise description is classifies requests concerning changes to, cancellation of, or status lookup for an existing customer order, requires the order number to proceed. It clarifies the scope and intent for the LLM during that initial classification, minimizing misclassification.
And finally, the topic scope, the contract itself.
This is your legal and safety boundary. The scope explicitly defines the limits of the agent's authority. You have to use clear, restrictive language. This is where you write, your job is strictly limited to providing non-financial status updates. You are explicitly forbidden from initiating any database rights or accessing PII beyond the last 4 digits of the account number. This contract is respected during the grounding check, serving as your essential safety rail.
Now let's drag home the critical rule regarding line of business, or LOB, logic. Instructions versus actions. This is where I think governance will fail spectacularly in early implementations.
This is the single biggest trap for transitioning architects. Instructions are for guiding conversation flow, sequencing, tone, and providing exception guidance. For example, if the customer appears frustrated, use empathetic language and suggest calling the escalation action. Actions must contain 100% of the critical business logic, period.
Let's use that high compliance scenario again. A 30-day refund policy. Tell me the right way and the catastrophic wrong way to implement that.
The catastrophic wrong way is to rely on an instruction. You write, only process the refund if the order date is less than 30 days old. The LLM might miscalculate the date, it might misinterpret a complicated exception rule, or it could be persuaded by the customer's emotional appeal. The non-deterministic output is a compliance failure waiting to happen.
And the correct deterministic approach.
The validation logic must be hard-coded inside the deterministic component, a flow or an apex action. The action, let's call it process refund, takes the order ID and returns a definitive Boolean can process, true-false result, maybe with a rejection reason code. The action handles the exception based on absolute code. The instruction then tells the agent how to communicate that result with empathy, but the actual decision was immutable and audible. The action decides. The instruction advises on communication.
That makes the design of the actions themselves absolutely paramount. They need high-fidelity metadata for the Atlas engine to reliably select and use them.
They require 3 metadata layers. First, the action name, the API name. It has to be clear and descriptive. Get order cancellation window, not OCW. The LLM needs to know exactly what the tool does just by reading its name. That helps in step 4 selection.
Second, the action instructions. This is the specialized description for the LLM.
Right. This needs to be 1 to 3 sentences. Explain precisely what the action does, when to use it, and list the required inputs. For a complex external API, the instruction might say, this action retrieves the current financial standing and account eligibility from the MuleSoft service. Only use this when account verification is complete and you need to check credit limits. This prevents the LLM from trying to use a financial API when the user is just asking about a knowledge article.
And third, the action input instructions. This sounds critical for data quality collection from the chat session.
Absolutely crucial. If the LLM has to parse user-generated free text to find an input for a deterministic action, you have to govern that extraction. You must define the exact format and validation requirements. If the action needs a date in ISO 8601 format, the instruction should state, the customer's date of birth must be extracted as YYYMMDD. If the customer provides January 1st, 1990, you must convert it to 1990-0101 when before passing it to the action. This forces the LLM to act as a data cleaning and parsing layer before calling your robust deterministic action. It minimizes runtime errors.
Okay, we've thoroughly dissected the execution engine, the control mechanisms, and configuration hardening. Now let's address the mandatory architectural dependency that supports this entire structure. Data 360. The guide is unequivocal on this. Agentforce needs Data 360.
It is not an optional feature set. It is an integral layer of the architecture. Agentforce, as we've seen, is the orchestration platform. Data 360 provides the essential context, memory, and accountability layer necessary for any enterprise-grade operation. Without it, your agent is just a fragile, non-governed chatbot.
So what are the specific architectural necessities that Data 360 provides? What makes it non-optional for a full governed implementation?
3 core necessities, all tied directly to governance and scale. First, the RAG infrastructure. Data 360 provides the core indexing and fragmentation necessary for retrieval-augmented generation. If your agents must ground their responses in unstructured data policy documents, technical specs, external PDFs, that data has to be secured, indexed, and made available via vectors. Data 360 provides that plumbing.
Which directly impacts step 7, the grounding check.
Exactly. Without a robust RAG infrastructure, the agent cannot reliably validate its own output against authoritative sources. That dramatically increases the risk of hallucination and compliance breaches.
Second, the governance layer, analytics and audit.
This is critical for compliance, especially in regulated industries. Data 360 transmits all the usage data, every utterance, every action taken, every observation received, every prompt sent to the LLM. It uses that to generate agent analytics, reports, dashboards, and crucially, it provides the mandatory AI audit trail and feedback logging. This means you can trace the agent's reasoning loop turn by turn and identify exactly why a decision was made and which instruction or action led to a specific outcome. You cannot govern what you cannot audit.
And third, scale and federation. For global organizations handling petabytes of data across disparate systems, this is where a Data 360 becomes unavoidable.
Right. Data 360 ensures long-term viability by supporting massive data ingestion volumes and enabling true data federation. It allows the agent to access data lakes, external data warehouses, legacy systems. Without this layer, your agent is limited to data strictly within the core CRM, which renders it pretty ineffective for comprehensive enterprise workflows.
Let's delve a bit deeper into the extensibility levers that use Data 360, moving beyond just the mandatory. What high-value optional features really elevate the agent's capability?
Well, the platform allows for BYO LLM, bring your own language model. While Agentforce provides excellent foundational models, regulated organizations or those with very specific performance needs might require a custom, fine-tuned model hosted elsewhere. Data 360 structure allows for seamless switching and integration while maintaining the security and the audit trail regardless of the underlying LLM.
And the integration of specialized data sources.
Yes, the capacity to integrate diverse external data sources and unstructured data for enhanced grounding is key. If your agent needs to pull technical manuals from a SharePoint folder or pricing data from a lockdown SAP instance, Data 360 provides the secure index connectors to make those sources queryable by the Atlas Engine's RAG component.
Finally, the value of real-time data graphs. This sounds like data normalization for AI reasoning.
That's precisely what it is. It addresses the silo problem. Agents often need near real-time grounding from multiple normalized Data 360 sources simultaneously. Customer profile data from one system, order history from another, and credit status from a third. Data graphs stitch this complex, disparate data together into a single, contextualized view. This prevents the agent from making decisions based on conflicting or outdated data points. It ensures a single source of truth for its critical reasoning tasks.
So the conclusion on this segment is definitive. Agentforce is an orchestration platform. Its effectiveness, its governance, and its long-term scalability are intrinsically bound to the Data 360 layer for context, memory, and accountability. You simply cannot build enterprise-grade compliant agents on an insufficient data foundation.
It's the cost of admission for truly autonomous execution in the enterprise. It's not a nice to have.
Okay, let's bring this critical deep dive home. We've dissected the shift from prescriptive automation to controlled non-determinism, forcing architects to master the levers of the Atlas engine.
The transition is profound. You are no longer coding if-then statements to map every single possibility. You are defining the agent's playground, its tools, and its unbreakable guardrails. You are coding the rules of selection for the LLM, not the answer itself.
And the Atlas engine is designed to respect those guardrails, but only if you use the right mechanism for the right job. Deterministic code for logic and non-deterministic instructions for conversational guidance.
Absolutely. And we identified the single biggest threat to a successful, compliant agent implementation. Relying on those non-deterministic instructions for critical business or compliance logic that should be hard-coded into deterministic actions or enforced by conditional filters.
So if I am a senior practitioner listening to this, what is the immediate mandatory task I should execute this afternoon to audit my proposed Agentforce architecture?
You must perform a critical business logic audit. Look specifically at your non-negotiable compliance, security, and financial rules. The 30-day refund policy, the PII masking rules, the verification steps. If that absolute logic lives anywhere other than inside an executable action or enforced by a conditional filter checking a custom variable, you have introduced a high-risk security and accuracy flaw.
That's powerful. You must ask, where in your architecture are you currently tolerating ambiguity?
That is the core question. Ambiguity, when you integrate it with an autonomous execution engine, immediately becomes an architectural liability. Use the Data 360 audit trails to confirm that your critical decisions are traceable back to the deterministic code, not to some fuzzy semantic interpretation. Fix the determinism gap before you deploy.
And that wraps our deep dive into the Agentforce architecture. If you found this discussion indispensable, if you need complex executive-level topics broken down without the marketing hype, you need to subscribe to the CRM Position podcast. We deliver the real state-of-the-art and the actionable insights technical leaders require to stay ahead of these rapid platform shifts.
We'll see you next time.